Now let us look at the next problem, which is about the majority element. Now let us first read out the problem and then try to see what can be the solution we can find out for this problem. The question says, write a function which takes an array and prints the majority element if it exists, otherwise prints no majority element exists inside the array. And they are giving the definition of the majority element. It says a majority element in an array A of size n is an element that appears more than n by 2 times. Hence there is at most one such element can be present inside this array, but not more than one element. What do I mean to say by this? Now let us say we have an array like this. This is representing an array which is having some values inside it. So the values are 4, 2, 1, 4, 3, 3, 6, 4, 4, 4. So the total index locations are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So there are total 9 index locations in this. So from 0 to 9, that means a total of 10 index locations. 10 index locations. Okay. Now let us take one more array for example purposes. The second array is like this, which is 4, 2, 1, 4, 4, 3, 6, 4, 4, 4. So again, what are the total number of index locations here? The total number of index locations are 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. Again, there are total of 10 index locations. Now what is this majority element? The definition says a majority element is the element which appears more than n by 2 times. Element, it says element which appears more than n by 2 times. N by 2 times. So here in the first case, does there exist a majority element? Now I'm not writing an algorithm here, just to explain you what is a majority element. I'm just counting what is the number of times an element is appearing. So in the first case, in this array, we have a number 4 which is appearing 1, 2, 3, 4 and 5. It is appearing 5 times. We have a number 2 which is appearing only one time. We have a number 1 which is appearing only one time. We have a number 3 which is appearing 2 times, and we have a number 6 which is appearing only one time. Now does there exist a majority element here? No majority element. Why? Because even though 4 is appearing 5 times, but it is not appearing more than n by 2 times. So for an element to be a majority element, at least it should appear more than 5 times, which should be 6. If 4 exists 6 times, then it can be a majority element. In the second case, how many times 4 is appearing? It is 1, 2, 3, 4, 5 and 6. So it is appearing 6 times, where the total numbers are 10. Therefore it is appearing more than 10 by 2 times, which is 6. Therefore here 4 is the majority element. 4 is the majority element. 4 is the majority element. Okay, now solving this problem is very easy. I know you can easily write a program. Even any new programmer, he can easily write a program. But the problem or the question here is not about just writing a program. The problem is write an efficient program. Write an efficient program. Now can you solve this problem? I'm just for spoiler alert, I mean just for purposes, you have to solve this problem in order of n time. Can you solve this problem in order of n time, which is again very efficient? Okay, now to solve this problem, there may be many problems which exist. There may be different kinds of solution which exist, which you may feel that it is very easy. Now we'll take all those possible solutions here and we'll try to find a majority element in those solutions, and then again we are going to find out which of the following solutions that we have done is the most efficient one. So the very first method, what does this very first method says? So the first method says that we have two loops which keep track of the maximum count of all different elements. If the maximum count becomes greater than n by 2, then break the loop and return the element having the maximum count. If maximum count does not exist more than n by 2 times, the majority element does not exist at all. Now, how do you find a solution like this? I mean, how does this first method applies? Assuming that this is an array which is having the elements 4, 2, 1, 3, 3, 3, 3, 1, 2, 3, 6, 3, 3. Now, what is the total number of elements here? I'm just making sure that there exists a majority element. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 and 11. So there are a total of 12 elements. So how many times 3 is appearing? 1, 2, 3, 4, 5, 6. So at least it should appear one more time. Okay, let us say this is also 3. Okay, for example purposes. So 3 is appearing more than one time, so it is more than by 2 times, so therefore 3 is a majority element. Now how this entire approach here, how it is implementing? For this we are going to take a loop a and I, and we are going to take j. Okay, compare I is j, if I is equal to j, and take one more variable count which keeps track of the count of an element. I mean, how many times an element is appearing. So initially the count is only 1. Now let us assume initially the count is 1, that 4 is appearing only one time. Now is 4 equal to 2? No. If no, then do j plus plus, else do count plus plus and make j plus plus. Okay, so I mean, if these two elements are equal, then increment the count, otherwise just increment the value of j. So 1 and 4 are not equal, 4 and 3 are not equal, 3 and 4 is not equal, 4 and 3 are not equal, 1 and 4 is not equal, 3 and 4 is not equal, 3 and 4 is not equal, 4 and 6 is not equal, 4 and 3 is not equal, 4 and 3 is not equal. Therefore 4 is appearing only one time, and then after the end of this loop we are going to compare count with n by 2. If count is greater than n by 2, then we can say it is a majority element. Okay, next time increment the value of I. Okay, so how does that work? We are going to increment the value of I. Okay, so what we are going to do, make I point to this and j point to this. Now 2 and 1, they are not equal, so count is initially 1, so 2 and 1 are not equal, so increment the value of j. 2 and 3 are not equal, 2 and 3 are not equal, 2 and 3 are not equal, 2 and 1 is not equal, 2 and 3 is not equal, 2 and 3 is not equal, 2 and 6 is not equal, 2 and 3 is not equal, 2 and 3 is not equal. Therefore after the end of this loop the count is not incremented, therefore 2 is not a majority element. Now again perform exactly the same operation, just increment the value of I. So next time the value of I will point here and j will point here. So initially 1 is only one time. So compare this, 3 and 1 is not equal, 3 and 1 is not equal, 3 and 1 is not equal. Now 1 and 1 is equal, so count is 2. That means 1 is appearing 2 times. Increment the value of j, again not equal, not equal, not equal, not equal, not equal. Therefore 1 is appearing 2 times, which is not greater than 12 by 2, which is not greater than 6, therefore it is not a majority element. Okay, now next time increment the value of I, so I will come here, again initialize the value of count with 1. So compare I and j. Now this 3 and this 3 are equal, so count will be 2. Increment the value of j. These 3 and this 3 are equal, so count will be 3. Increment the value of j. This 3 and 1 is not equal, increment the value of j. 3 and 3 is equal, so count the value will be 4. Now again 3 and 3 is equal, so count will be 5. Again 6 and 3 is not equal, increment j. 3 and 3 is equal, so count will be 6. Again increment the value of j. This 3 and this 3 is equal, hence the count will be 7. So after the end of this loop, again if you are comparing the value of count with n by 2, you can see count is greater than n by 2, hence there exists there exists an majority element which is 3. Okay, so for this particular array 3 is the majority element. Okay, now this is the easiest method, or even the most basic method to solve this problem, but this method will take order of n squared time. It is like order of n squared as a time complexity. And what will the space complexity? Space complexity will be order of 1 as space complexity. Order 1 as a space complexity. Now the question is, can you solve this problem which is taking any algorithm which is taking less than order of n squared time? If you can write down an algorithm which is taking less than order of n time, that will be more efficient, although as you know, but the goal is to make it as efficient as by making as order of n. Can you solve this problem in order of n time? Solving the problem is easy. I know you can do it. I know I can do it. Everyone can do it, right? So solving the problem is easy. But the question is not about solving the problem. The question is, can you solve this problem in more efficient manner? Okay. Now in the upcoming videos, in the next video, let us try to see one more approach to solve exactly the same problem. Okay. Let's see you in the next video.